Hey guys, this is my talk on railway-oriented programming in C#. Presented this talk at DED a couple of weeks ago. I'm going to share it with you guys, so I hope you're ready to learn something. A little bit about me, my fabulous photo as well. Work at Ratify, senior developer. Got my email address there, Twitter handle. I only just got Twitter, by the way, so don't spam me too much. Bit of GitHub there as well, if it interests anyone. So a bit of prerequisites for this course. So I hope you guys all know C# very well, with this alternate group anyway. But you don't need to know anything about functional programming. I'm going to try and dumb this down. This is the analogy, which is the railway in the railway onto programming. C# experience, yeah, and I hope you have a basic understanding of trains as well. So just to set the scene here. So this is actually probably about a year ago when I did this. So I got the idea off actually from AltNet itself. It was a past talk that I watched when I came here. I was actually working at AGL at the moment, consulting in a team, and we were doing APIs, as a lot of people probably do these days. And what ends up happening is there's a lot of discussion around code cleanliness. So code cleanliness comes up quite frequently. How pretty code can look and where we're going to move the code and stuff like that. Definitely differs to code quality, and that's probably something we should all aim to have, but the cleanliness itself can tend to waste a lot of time as you discuss this sort of stuff. So this is, well, how I'm trying to help out with cleanliness. So the problem. What we're going to do is we're going to go through this example of learning how to do railway oriented programming, which I'm probably going to say ROP for instead of ROP, but hopefully get that. So it's an example project. So we're going to top up a Mikey card. Everyone's done this, right? Well, hopefully you get the kind of picture behind this. So we're going to write an API for it. It's just an example. So don't think that any of this code actually matters or is legit. It's just all entirely fictional, just to prove a point. It's got different kind of things that we're going to try and cover to get across this. The purpose of this, is to convey a problem that we're going to try and solve. So here we go. We've got our basic steps. So to solve this problem, we're going to go through. We're going to validate the request. We're going to charge the credit card, and hopefully it's successful. And then we're going to update the balance and print a receipt. So you can see this is generally how your code would probably start off as. So you start to write your code away, you plug in away, doing some actions, and then it comes out pretty simple, right? You got yourself, well, you're validating some of the requests in here. You've got charging the credit card, updating the card, and then returning a receipt, which is our model at the bottom there. It all looks very well and pretty. It doesn't have very much error handling or logic or whatever. So this is generally how it typically starts off as. So we go, all right, well maybe we need to throw in some null checks. Everyone loves null checks. So you go, if and those equals null. We've got some conditions that when we hit functions or methods and they're going to return something, so we've got to check if that's going to be accurate or not. So we'll throw in some more checks. And obviously there's probably someone who's going to throw an exception, so we're going to wrap it all up here. More nulls, update the card, putting some more logging as well, because everyone loves to log and make sure, if something does go wrong, we can diagnose and debug this, right? Got some different status codes that we're returning as well, just in case something goes wrong. Basic validation there. But you can see how the code is basically just blowing up. So now we've got all these different types of ways that we're handling all these errors. You kind of lost what realistically is the point of the code now. It's a bit harder to read. You can't just scan it just as easy as you did before, right? You just go, you did that. It's kind of really blowing up and out. This takes a little bit longer to digest the code as to to find out what the actual purpose of this is. I'm sure this happens to everyone. So this is actually 6 lines turned to 19 lines of code. So how can we make this more readable without actually sacrificing any of these checks, which is what we're going to try and achieve. Before we do, so as we're going back to when I was in AGL and the code cleanliness that we constantly come up with, we get MVC. Everyone knows motor view controller. I'm sure you've all done it plenty of times. So I remember back when, I mean, it's actually an old framework, by the way. It's 1970, believe it or not. It's a pretty surprising number. Popularized by Ruby on Rails, and yeah. So I remember doing this sort of stuff when I was a PHP developer, believe it or not, before I started coming into C#. And all the time you would get the constant argument over where the business logic lies, and it's like the fat controller or the fat model. So you start off developing and plugging away, and your controlled actions will just expand, and then you plug that into the model, and then that gets all fat, and it's a lot of discussion online. I mean, this is a bit of an old problem, but realistically the answer to that is that your business logic doesn't lie in this pattern to begin with, but regardless of that, where does the business logic go? That's quite a common kind of problem that you kind of see pop up, and especially when there's so many different frameworks and different design patterns and stuff like that coming a long way. So everyone loves Martin Fowler from ThoughtWorks, and he's written a lot of books on a lot of different stuff, and he's come up with the concept of the service layer. And this is quite a popular design pattern. This is the one that we were doing at AGL at the time, was the service layer. I've actually read the book and the chapter on the service layer, and the way that it's been implemented is quite a lot different than the actual way that we've implemented it. But I see this kind of stuff happening quite often. So you get your controller, hits one of the actions, you get one of your models, and then basically you just pass it to a service layer to manipulate, and then return back, and then return. And I've seen this in a lot of APIs. I'm not saying that you guys do this or anything, but that's kind of what I see. But the problem with that is the problem still existed of where the business logic lied. The problem then just got shuffled from fat controller to fat model to now fat service layer. So we're constantly just keep moving this problem to just different areas. And there's also lots of other different ways, for instance, they've tried to solve this problem as well, such as model VB model as well, which kind of tries to get rid of the service layer, this business logic kind of thing. CQS, MUV, which I discovered the other day, which is kind of around CQRS kind of stuff, but more or less, the problem keeps reoccurring. So what we really want is we want to be able to have a separation of concern in our business logic. We want to be able to reuse some of this code and tie it back up together. And this is the problem that we had at AGL, is that, again, a big object, we call them God objects, to be honest, doing everything. I want to divide this up. I want to make this reusable. I want to get rid of the error handling logic. I want to have the code clean, easy to understand, and then be able to plug into a little bit of functions and make that reusable. And we compose together those functions to make this happen. So we'll run over the goals real quickly. So you've got happy path code without sacrificing any error checking. So the code is going to have the exact same errors checking as beforehand that you saw originally, but we're going to make it look like the happy path that you originally saw beforehand. We're going to remove this God object that keeps coming up, and then slam it down and hopefully separate that up so we can make that more reusable and more usable. We're going to make the controller show the data flow, because that's the whole concept of MVC, is to have these controllers show where that model goes and how that's been manipulated. So we want to try to see if we can grasp that and make that a possibility, rather than just having an action just call a service and return it, which is pretty common from what I've seen. Also, we love functional programming, because functional programming is pretty cool. So we're going to introduce some functional programming concepts and hopefully have some fun doing it, right? So C# and functional programming isn't really that new. It's there's a few other talks I've gone and seen as well with how much C# has been influenced by other languages, including functional programming languages, and hopefully you guys can see some of this stuff as well. So C# 3, I think it was, introduced Lambda and Link, well, Lambda expressions and Link. Nowadays we've got better tuple support, or tuple, however you want to pronounce it. It's always an argument. We're getting pattern matching as well, which is pretty cool. Local functions, I don't know if you guys have used this local functions much, but you can write functions within functions, and what we call methods, but write them in there to do different actions on your link statements or whatever. And there's quite a lot of other stuff as well. So expression body members is something new as well, which I'm seeing a little bit of mixed opinions about expression body members. I'll show you some anyway, so you can kind of see what it looks like, and if you have never used it before. So this overall is a functional approach to error handling. This is actually taken from Scott Wlaschin. I hope I pronounced that correctly. From his great blog. Well, it's kind of more of a website, but it's got lots of his blogs on there if you're keen to ever learn it. So he goes into detail about, teaching functional programming for people who work in the workplace. Also inspired from AltNet, as I mentioned previously, and this is what gave me the idea to go ahead and do all this. There's another guy on the line, because there's not much you can find about this in C# really, called Vladimir, I can't pronounce it. He's an Microsoft MVP from Washington, D.C. He's actually got some good blogs about it, and he's done a video of it on Popularised. I haven't actually watched that, but it should be pretty interesting to go to see if you're interested in all this sort of stuff. So again, the railway is the analogy, and we'll get the happy path programming. This concept as well, it is rather simple. It sounds confusing at the start, but once you kind of start grasping this, and you got to hold on through this as well, and when it all comes together, it kind of makes a lot of sense and starts to click. But getting to that point is takes a little bit to get through. So you're going to bear with me on some of this sort of stuff. Introducing ROP or ROP, however you want. So we've got our main kind of metaphors on this analogy, which is the result, which doesn't really make sense in the railway checks, but we've got our tracks, we've got our functions, and we've got our switches. So the tracks are basically our actual functions themselves, and we're going to define them in certain different categories in order to join them up. Switches are how we're going to join up, and our tracks is also going to show they come down and success or fail. So this here's a little example, and I did spend a lot of time making all these diagrams. It says input there, right? Hits the function, and you can see there's a little box around there to represent what the function is. And it comes out as a success or fail. So this is the track here, and that represents the function. So moving on. First of all, the result type. This is probably, I've actually seen this result type used in a lot of different projects, a lot of different companies, regardless if they use ROP or anything or not. It's just there. It's even if you don't intend to use it, it kind of still pops up. So this is the result type, which holds either if it's successful or it fails. It can hold an error when it fails. So if you're going, hey, look, it failed, I want to know why, right? Holds a value on success in this one. So if it does actually pass and succeed, it actually stores that successful result. And so this is how we're joining this up together. It's immutable, so it has to be recreated each time. The main benefit of that as well was that we actually transform the type each time. So if you actually make this, it's going to be stuck like on that same type. So you have to recreate it for every different type. So that's why it's recreated on each call. So just a little side to it here, and there's not much F#. This is the only F# in this whole presentation, I promise. This is actually now natively supported in F# 4.1. The result type is baked into this language. So this isn't something that we're creating our own one, but this is actually part of the standard library. It's also got two new keywords as well. So we've got error and OK, and they're actually just dictating what track we're on, whether it was successful or failed. So that's actually keywords now within the language. Sorry, I think it might not be the actual keywords, but it's like OK or error or something similar. Yeah. So we're not going to cover any of this F# stuff, by the way. And this is actually a lot shorter code as well, thanks to discriminated unions. So it's going to be quite a lot longer than a C# example. So we've got our result type in C#. So we have some code here. There's a lot of code in this, so you guys can get a taste of it. As you can see, it's called result, has T data. There's other ways you can do this with T success and T failure and have an actual object for your failure. But in this case, we're just storing the successful object here. Private constructors, static methods right here. So we're creating it from each one. Storing the data that we've got, and we're storing an error. And then whether or not it is successful or not. So we're saying, if it's successful, I want to create a success, I want to create a failure. I want to either store the error or store the data from that successful result. So how do we store these errors, right? So we've got our error type. So this is just basically how, you can do this in a lot of different ways, but in this example, how I did it was through an enum. Basically, all you're doing is just listing, just what errors happen. These areas as well are areas around business problems, right? So hopefully you get all the business errors all lined up in here. This can grow to be quite large, and maybe be too uncomfortable for some people. You can see here we've got our errors from our example, our validation one, our payment one, and our count one. So it does bring some benefits though, even though it's quite large. It keeps whatever, so you know it. It's type safe. Forces you to check them all as well, and a bit of type safety there. So we're not using strings or anything. So you kind of get to know that's just the error I'm going to get. Little detour into exceptions as well. So I like to say exceptions are for exceptional circumstances. Obviously, you're going to get exceptions regardless. There's a lot of people who like to throw lots of exceptions, which is fine by them. But the basic rule here is don't use it for control flow. It's quite slow for control flow as well. Can't really optimize stuff here. It's generally used for I/O. You get out of memory exceptions or something like that. So we're not trying to. What we're trying to do is we're trying to make all our business problems anyway, all our business errors come through that previous enum. We don't want to handle this through exceptions, but we will look at a way how we can handle these exceptions if you need to. So now on to tracks. So again, these tracks are going to show us that's our function, input, output. You can see here we've got our isAmount valid, which is one of our checks. It's basically, it returns a bool, it takes a decimal, it says if it's greater than 0 or equal to 0. So it's a valid amount that you want to top your card up. So you probably should just be greater than 0. So you want to top it up with 0. But this is how we're going to depict this. It's called a single track because it has an input and output. It doesn't return a result type. And the result type is what switches us off into success or failure. Right? So it's just in and out, simple. Right? It's a simple one to start you off with anyway. Next up, we've got 2 tracks, so it gets a little more interesting now. As you can see, we've got a validate amount, takes a decimal, returns a result type. So this is actually, now the result type is, again, right, has success or failure in it. As you can see, this is represented by, that's our function there, it's the input, and then we've got success or fail. So on whether it is successful or it is a failure, we're creating that result type with our static methods there, and then we're putting in our error, and we're putting in our amount if it's successful. We may not do anything with that amount, but just so we can continue the little train going on, which is our analogy for this. We've got another fun one, which is dead-end functions, right? So there's a lot of these. In function programming, you have to return something. In this, C# object-oriented, you don't. So in order to cover for this sort of stuff, we've got our dead end. As you can see, it kind of hits a little dead end there. This is our update card. Now, again, this is just a wide example of what's going on here. It's a account update. It doesn't return anything. We're just going to pass it some data. We don't care. Right? Again, probably won't happen in the real world, but this is just to show how we can do it. Other ones we've got is supervisory. So again, when we want to have part of our unhappy path was that it did have logging and it did have a lot of error with some of the logging, and we can also chuck metrics and stuff into this example as well. So this is how we depict this. So we've got 2 tracks on success or fail. There's no result here, but both tracks, it'll use it for logging, success, fail, and it's going to execute something on that, right, on each one. And we'll show you how we're going to bind that together in just a sec with our switches. So we've got 3 main types of switches. You don't really need to focus too much on the different types. The main one we're really just going to be using is the constructors, the adapters. The constructors get us into the result tape, and then the adapters are just going to join along until we finally end it. The combiners, however, we combine other tracks together, or I've never really done much with the combiners, so see how it goes. So the first way we're going to use the first switch is a bind. Now the bind's probably the most important one because it's the one that you will use the most, and it's basically what brings us all together. Is this bind one. It's an adapter block. It takes 2 tracks in, 2 out, and executes only on the success track. So you can see there is successful, right? And then we're going to return the switch function, or we're going to continue to fail, along the line. So you can see that depicted by this picture here, success and fail. That's our function. So it comes down, and then this here is our little. It can change tracks, right? It can go from the success to the failure track. and that's shown by this switch function here, right? In this little example, we've got a func, but you can see in our func, it's returning result t data out. So a func's going to model our lambda or our delegate or whatever, and our func is in data or and then out data. So it's in for every generic argument except the last. And the last one, we're returning results. So this function, wherever it's defined in your code, right, is going to return its own success or fail, right? If it's already failed, it's just going to continue on the failure. It's got t data out there because we're actually recreating that result and we're redoing it out and we're redoing that on the failure track. So if we're already failed, we're just going to go straight through and we're going to change the type based on the t data out. If we're successful, we could go that way, or we could go down that way. Another switch that we've got, this is also again another adapter block, and it's one track in, two tracks out. So this is our map, is what we're going to call it. This is the functional programming terms as well, but we can get to some more interesting ways to name this in a second. And import is successful, so we're just going to execute a single track function here. So this function doesn't return a result type. That's the trick on this one, right? That doesn't return a result type there. That one just returns normal data. So it's not going to change the tracks. This is going to be successful or it's failed. So as it comes down to the success line here, we're just going to recreate the success with the new data, and we're going to call that function, chuck the data into it. You won't be able to switch tracks here. You're just going straight through. So there's no switch. You're just going to execute something and keep going. We've got another one, double map. This one's pretty cool. One of my favorites. So double map here takes two functions. They don't return a result type. Go through. So just like the map, but in this case, we're gonna execute it on success and execute it on failure. So this is how we're going to use our supervisory functions as well. So when we've got something on a log success or did this work, yes or no, this is how we can plug those together, right? T. So you all remember our dead end function and how we're going to deal with that. So T is probably this. It's a bit of a wrong name for this because it's also called tap by some functional programmers. It doesn't really tee off. It just kind of goes off into a dead end. But it takes a dead end function. And so this here is because it's an action. Because an action doesn't have a return type because it's not a func. Right, so just taking a dead end. If it's successful, we're going to execute it. If not, we're just going to. Who really cares, right? Just keep returning what we got passed in through that one. So you go straight down there. So you're going to come off here, do something, and keep going. So now we've got some other, these are the constructor ones. So you have to bear me with this because it's all going to come together in a sec. This is the succeed. So maybe we are on a failed track, and maybe we just want something to succeed, right? So we've got a constructor, always on a success track. Takes one track, takes a function in there, and then returns a two track, which is the result type. And we're always going to turn the track on the success one. So this is what we can use here if we just want to put in a bit of make it call a function, but this function is just going to roll us down the success line. But it's going to give us a two track, so we can join them together. We got a fail as well. So exactly the same as a succeed. It's just going to do the opposite. It's going to force a failure. Don't really use this, but just to keep it consistent. So again, we still have to deal with exceptions, of course. So this is an example of what's known, or what they like to coin as a lift. So we're going to get something and we're going to turn it into a two track, which is one that has our result type. So we're going to deal with exception handling. Now this is our little Pokemon exception catcher there, but you don't really want to do that. You maybe make this more specific. But we're going to return, we're going to accept our input. Again, this is an extension method from the result type. We're going to go is success, success or fail, chuck our single check in there. If it throws an exception, we're going to return a result of fail. So that way we're going to come down here. If an exception occurs, we're going to go down the failure branch. If not, we're going to go down the success one. So that's how we can deal with our exceptions. This is another example of a lift. This is the only other one after it. Oh, there's only the second one. Boolean to result. So Again, it's like the exception code when something was thrown. I'm going to chuck that down the failure one. This one, if it returns false, I just want to fail. So we're just going to run input success is success. If it is successful, we're going to run our single track function, connect this up together, success and fail. So if it is, I'm going to use ternary operator. If it is success, then succeed. If it returns false, it's going to fail. So and if it is already on the fail branch, so if it already is coming down the failure side, you're just going to continue on and fail. And to kind of get all this wrapped together, you can't return a result type to an API. They're not going to know how to deal with it. The front-end guys won't look at results and be a bit questioned about it. So we need to kind of just bring all this together. And so there's lots of different ways you can do this for all the different kind of frameworks or whatever you're using. But in this kind of example, this is how we bring it together when I was doing this at AGL. So we basically have a handle function, which we call last, which then, based off of the error codes that we get, we're going to return a different type of request. So if it's successful, we're just going to go OK and then chuck the data in there and send it back off to them. If we're on the failure slide or failure track, we're going to go through a switch case, just a basic switch case with our enums of what different errors that we've got, and return, for instance, bad request if we've got those details, we've got those errors, payment failed, or again, completely hypothetical example here. Don't worry about what it actually is. Just to say, and if you don't know what it is, then I'm just going to throw a 500. So how do we make this in action? I'm sure you're all excited now. So having that knowledge you've got going forward, we're going to try and go back to our Mikey example, connect these all up. We've got to define our little tracks, connect them all up with our switches, and then make it all flow through. So we can see that happy path and make it run down the fail track if it's going to fail. So first off, we'll start with our validation. Now, pick this one first because we're going to play this a little bit differently. As you can see, we've actually made two methods for this. They're returning the result type. As before, we just had that at the top of the code. You don't have to do this. Again, we could have just done the Boolean lift, but because this is such the most common example here, it's probably best to start with it. So a validate amount accepts an amount, returns success or failure based off that amount, and then that's the result type there. So you can see if it is a valid amount, you're going to get succeed. If not, you're going to get fail. Same thing for the account number. I might have missed some stuff there, but validation continued. Okay. Two-track trunk function. So now this is what we're going to look like. Well, we're starting to build it now, as you can see. This is our post where we post back our results for our Mikey update. We're going to validate it first, which is the first part of our little steps that we're going to go through. We're going to return. We're going to handle the result type. So if it gets any of those errors, we're going to get one of those status codes back. And we're going to use our bind to bind the previous two, these two here. We're going to bind them together using bind. So if it comes down the failure side here, if this one validate account fails, then once it's binded, as you remember in the bind example, it's only going to execute on success. If not, it's going to return a new result type of type fail, and then with the same type, with a different type. So you're going to go down here. If it does fail, you just keep going down. If it's successful, you keep running down the success line. And then that's when you keep going down the success line, then you can actually execute that validate amount. And that will occur again, right? So if it's a valid, you go down the success. If not, you're going to go down the failure. So starting to join this together in our little example here. So now we've got our credit card charge. So this one was our dead end function, I think it was. So basically, this is one that threw the exception. So in our previous SAD example, we had an exception being thrown and we had to catch. And if it caught the exception, then we're going to go down the fail. So you can see we're binding. We've added a new one, which is try catch, which was that exception lift one I showed you previously. That there is going to execute that. If an exception is thrown, we're going to switch down the failure one. If it's not, we're going to continue on to the success line. So this converts this here into a two-track, so it can be joined up by the handle one. And we've got our update card. This is our dead end one. So our dead end functions are handled with the T, as you can see. So it comes down here. So again, T is a bit of a weird name for it. So we're gonna go through and charge the credit card. Then with the T, we're gonna update it. We just don't care about the result. And this again, don't care, and then move on. And that's shown through this example here. Comes down there, updates that, and then just keeps going. If it's on the failure, it's going to keep running down through that failure track. So now we've got our log. So our double map here. This is how we're going to handle, because this is our supervisory functions, right? We need to have both success and fail, and they don't return a result type, so it's going to be map, and because we want success and failure on this, we're going to do a double map. So you can see on this one here, we've got, if it's successful, we're going to execute that, and if it's a failure, we're going to execute that, and that's showing through this. So it is going to execute a function there, whereas these ones aren't going to execute anything, it's just going to go straight through. It will execute something there, but it will continue down this side, either side, depending on whether it succeeds or fails. And then we're going to return our receipt. So the receipt is the model that we're going to create for our front end guys, so they can get and process it. If we're going to use a map, so you can see here we've got a new receipt. As you can see how we've got all these underscores as well, because these are the values that we're passing through each time with our result type. So that becomes the previous value of that. That becomes the previous value of this, and so forth. It passes through, it keeps going along. So we're going to create a new receipt. Again, it doesn't return a result type, so we're going to use the map function for this one. And this map and this then binds them all together. So if it's on the success line, it's going to create that for us. If it's on the failure line, we're just going to keep going. And before we get to our handle, we've got a bonus one. Right, so as we all know, C# supports operator overloading. This makes it a little bit more interesting because those concepts that we had, which were mind, bap, T, map, double map, whatever, they can actually all just be overloaded with some simple on success, on failure, on both. And now constructor ones can be succeed with or failure with. That's what's going to push us onto the track, depending on which one we're on. So this kind of makes it a little bit more usable, because those concepts, while they still exist, are kind of covered up by more readable words that you don't understand as functional programmers. This has actually made it a lot easier. We're basically trying to sell the idea or giving the idea a go with AGL, having on success and on failure, and definitely makes it more useful. And because when you actually start typing that, it's actually going to select the right type. So all you have to do to make this happen is literally just rename. This is the bind example here. Just rename it on success. There's nothing else you have to do to make this occur, right? And so now we're going to bring it all together. So this is the bit of the money shot, which is why I formatted it a lot prettier, but never mind. As you can see, we've got on success here and on success there. This one was once a T, or a T and off. That one was just a bind. But they're both called on success because it actually knows the actual type you're passing into it. We've got on both instead of double map. It makes a bit more sense. So on both, do this. On success, do that. And you can see how it kind of like joins it all together up at the end here. But this is what the full track looks like if we're going to give the example of our MyKey top-up card. Again, we're mutating that last part for the receipt, and you can see here like that's the transaction that's been passed and carried through. Again, it doesn't look as good as F#, so F# makes it look way prettier, by the way. All right, so after we went through all that and went through it, everyone learned something new, everyone gave it a go. Basically, we got some good feedback from it. Well, we got some mixed feedback as well. So I went around, asked everyone what they thought of it and see if they wanted to give it a go again and if they liked it and if they wanted to try something else or whatever. So this is basically the feedback that I got from the team that I was working on at the time. So they did like the fact that it did reduce a lot of the nesting. So you notice that there wasn't much nesting going on there with lots of different ifs, and try catches and stuff like that. It was just straight down. They did tend to find that it was more readable in the end. So you could actually look at that and decide yourself what this code actually did or what this action in the controller actually did based off just reading a few lines of code as opposed to spanning us across the 20-something we saw earlier. Much faster to recognize. Did show the data flow a lot better. There is some little tricks around this data flow because you notice how it is railway and programming. You're passing that value each time. they actually did suffer some little problems there, because in the concept a lot of people would develop this with, they would end up wanting to use a value that happened up here that they got returned from another function up there and chuck it down in there. So that doesn't occur too easily in this. You have to pass the values all the way down, and it takes a little bit of a learning curve to get the hang of that. A lot of this can be solved well with tuples or branching off again into another method and having that another method have those different values in it, and I can actually put that in scope as well if you do that. So it was a little bit of a learning curve at the start. Some of them probably still weren't too comfortable with it by the end. I think that the on success and on fail actually did make this a whole lot easier for them to understand. Going back to those bind, maps, and T's, I think those words just kind of scare people off a little bit. But the on success and on fail generally just work most of the time. And what you would see is a lot of in the service layer, when we had the service, or our service layer in this example with AGL, a lot of these had just different methods that just returned result each time. So no matter what, even if it threw an exception or whatever they're trying to handle, they just returned result. And the majority of one that they would use would just be bind, which would just look like on success. So that helped a lot as well. People also thought the code was cool, and I learned a little bit of functional programming. Well, just the starts of it as well. So what are some good use cases for this? So it did kind of work well for the API, but I'm now seeing it probably more useful in serverless. I think I'm going to go back to more serverless for this as well. I recently did another project where it was entirely serverless, and we really focused on just making our one function for the serverless in one file. So had a lot of different kind of discussions around people around this sort of stuff as well, and it's kind of a little bit of a mix, hit and miss. But the basic idea is a lot of these design patterns and these frameworks like AutoMap or AutoValidator, etc., are all basically all there to glue all these different pieces together. If you kind of just focus all your effort just on a single file as much as you possibly can, you can ditch a lot of these different frameworks and just really simplify this tech stack. So that's kind of what I've been pushing recently. And it makes it look really pretty if at the top of the file it just tells you what it does. And then it just comes all together as you keep reading the file more and more and more. Again, it's rather controversial, but it's possibly another discussion for another time. A lot of validation as well. I've seen this used for stuff like parsing XML documents and stuff. So if you keep going through that, I think that was actually the previous example here, was parsing XML. And state machines, actually I don't know about state machines. I should have taken that one out, to be honest, but maybe it could help someone. Okay, so let's recap our goals. So the code itself, again, did show the happy path without sacrificing error handling. It does force you to compose these functions a lot smaller together rather than having one big method. So you can actually bring them together, smaller functions, and compose them together for different things. And a good benefit of that is, especially when you're writing endpoints and you want to write an endpoint that does something very similar to another endpoint but just want to change one thing, you can actually compose the previous functions together and then add the new one in. And that kind of makes it a little bit more rapidly develop a lot of similar endpoints, which helps with, like, I don't know if you want to call it REST, but helps people make it more usable from an external party. The controller does show the data flow coming down. We did learn some functional programming concepts, and I had a little bit of fun doing it too. So got some slightly more advanced topics here. Async await. Yeah. So this is what's going to happen. You're going to run straight into this, and you're going to go, all that sounded really great, but now I have to write this async await, and how do we do that? So it's not too difficult, but it kind of gets a little bit tedious. Guess you need to wrap everything into task. And you can see also this one takes a task. So if you actually want to, if one of your functions is async, but the one before it isn't async, you've got to find a way to mesh them together. So this is actually going to be doubled up, and you're going to have one that doesn't take a task and returns a task, and one that has a task and has a task. So that way, the two that are binding together will call the two different functions, and you actually get this working with async await. So it's a little bit more trickier, but once you get the hang of it, you're just doing that, but just wrapping them in tasks to return. And you tend to find as soon as you get one with a task, they're all tasks after that. So CQS, so let's do QRS, but close enough. Coming a bit more of a popular pattern recently, I'm kind of see. especially if you're at DDD. It was mentioned a couple of times. So it basically it's got the similar kind of concept to it if you want to take it this way. Instead of having the action process this, you're just pushing into a command, and you've got a command handler that does the same sort of work. Basically, you're just moving it away. It works really well if you've got message buses coming in or something, as well as the data actions. You want to share that kind of logic across. So once a message comes in, you can handle that sort of stuff there. You can probably check that out. I haven't actually done much of this with ROP myself. Again, Azure Function, AWS Lambdas, keeping it simple. I think it's probably the strongest direction this could possibly go in. And finally, we got some resources. So this was the Pluralsight, as you can see, where that guy had it. This is actually a QR code to my slides. So if you can snap it and go check it out. This realistically is only what you kind of need to make this happen, is what's all included in the slides. So despite that, it's you can go look at it online. There's not too much about it online, so maybe this will help. And really, if you're interested in learning further, you can probably go learn more about functional programming. Thank you.